So here's the problem. At what Celsius temperature will 1.02 moles of gas particles occupy 24.5 liters and exert 1.17 atmospheres of pressure? Let's list out everything we have here in a list of knowns and unknowns. We want to know what temperature we have. So we don't know the temperature. We're going to put a question mark there. We do know it needs to be in Celsius, so I'm going to put a little notation here. I need degrees C when I'm done. Okay? I've got 1.02 moles. Well, I stated earlier that moles are symbolized by the letter N. So our variable for moles is N. We've got 102 moles. Okay, we've got 24.5 liters. You should know now that volume is measured in liters. 24.5 liters. And it says that the pressure is this. So that made it easy for you. You got P equals 1.17 atm. So we need to find an equation that will fit all that. T, N, V, and P. The only equation that includes all those things is the ideal gas law, right here. We've got, let's write it out here for you. I've got PV equals nRT. So we have T in the equation. That's right there. We've got N in the equation. Right there. We've got V in the equation. Right here. We've got P in the equation. It's right here. The only thing that the problem doesn't give you is R. But you always have R. Recall that I told you that the values for R are on the front page of your test references. R, the universal gas constant, R, is one of these four things here. And you have to have all of it. Now, just a word of warning. Students do this from time to time on tests. It's one of the most common mistakes students make when solving problems like this. They assume incorrectly that L is a variable. That is to say, you can plug a number in for L. You cannot do that. L here is a unit of measurement. You can't replace a unit of measurement with a number, nor can you replace atmospheres or kelvins or moles. Okay? These are units of measurement, 4 units of measurement that are part of this constant. Okay? And the same here for these 3 as well. What we need is a value of R that matches the units of measurement that we already have. So let's look up here at the units of measurement we have. We have moles in. Okay, there's moles. We've got volume in liters. There's liters. I'm sorry, let's move it down here a minute. All right, so here's N is in moles. Okay, so I've got moles here on all 4 of these right here. Okay, I've got liters in all 4 of these. There's liters, there, 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 and there. But I've got pressure in atmospheres, and this is the only value for R that has atmospheres. This is millimeters of mercury. This is kPa. This is torr. This is the only one that works. So R for the solution of this problem must be this one right here. So R for this problem is going to be 0.08206 liters times atmospheres over Kelvin times moles. Now we have all the values we need. Now that we have R, we got everything we need to find temperature. So let's plug in. That's the next step. We found our equation. We're ready to plug in the values that we have. So temperature we don't know. We're going to leave it alone. We do have P, 1.17 atmospheres. We do have V, 24.5 liters. We do have N, 1.02 moles. We do have R, 0.08206 liters times atmospheres over Kelvin times moles. And we do have, and we don't have T. That's what we're trying to find. Okay. Now, one of the problems with solving these problems, like these kind of problems like this, is because we need all this space beyond here that we're going to need to we're going to need really to turn our paper the long way. So I'm going to change this around. I'm going to put a longer sheet of paper and transfer this problem out to give us some more space to work. 1.17 atmospheres times 24.5 liters. Then I've got 1.02 moles, and multiplying that times 0.08206 liters times atmospheres divided by Kelvin times moles, and then we're multiplying that times a temperature. What we're going to need to do, the next step is always the same. We're going to need to isolate our unknown. Our unknown is T. To do that, we've got to multiply by something that's going to get rid of this. That's 1 over 1.02 moles. We've got to multiply by something that's going to get rid of this, so we've got to flip this around. Kelvin times moles over 0.08206 liters times atmospheres. I still didn't leave myself enough room really to do that, did I? Kind of got it on two different levels here. I could have written smaller, and that's kind of a problem when I'm doing these things. For you guys, I write with really big pens. Let's make it a little bit smaller here. We'll do it again. 1.17 atmospheres. I hope you can follow it when I write it smaller. Suppose if you write big, you're going to have to probably learn to write smaller or get really big paper. I kind of written really small over there, but we'll see how it works out. Remember, I added these two steps here, so if I did it to this side, I've got to do it to the other side. Anything I do to one side of the equation, I've got to do to the other. So I'll put those same things on this side over here. All right, let's see what we got. We can cancel 1.02 moles here and here. We can cancel the 0.08206 liters in atmospheres. All of that's going to cancel here and here. Kelvin and moles is going to cancel here and here. So what we have left then is temperature. We've isolated the temperature all by itself. Let's look at the other side of the equation. Any number over 1 is just the same number. You divide by 1, you get the same thing. So we're going to put those over 1 and look and see what we can cancel. Let's see. We can cancel moles here and here. We can cancel atmospheres here and here. We can cancel liters here and here. And what we have left is K, which is our unit for temperature. So our measurement unit we have left is matching what we are looking for. Okay, this is a lot of stuff spread out a long way, so I'm going to condense things, okay, a bit. We've canceled everything over here except temperature, so I'm going to write it this way. Temperature here. I've got 1 over 1.02 moles. I've got Kelvin times moles over 8.08206 liters in atmospheres in the bottom. Put this here, Kelvin times moles over 0.08206 liters times atmospheres. I have 1.17 atmospheres over 1 and 24.5 liters over 1, and we canceled everything but Kelvin, didn't we? All the units anyway. So moles canceled, liters canceled, atmospheres canceled, and we've got Kelvin left. All right, so now we're ready to plug all this in the calculator. So we got 1.17 times 24.5. And we're going to hit enter to get a kind of a big number here. Then we're going to divide by the first number in this bottom series, 1.02, and hit enter. And we're going to divide by the second number in this bottom series, divided by 0.08206, enter. And this is the answer for temperature we're looking for, at least for now. 342.4682083. The only unit we have measurement unit we have left is Kelvin equals T. And we can round this off if we want to here. We can round it off here or in the next step. I'll tell you about that in a minute. 3 significant digits here, here, and here. Those are the least significant digits. Let's round it off to 3 significant digits. So 342K equals T. We've got to be careful here. You always need to go back and read the problem. Make sure you're giving the answer you're looking for. And the question says, what Celsius temperature? Well, this is not temperature in Celsius. It's temperature in Kelvin. Well, if you add 273.15 to Celsius to get Kelvin, you get Celsius by subtracting 273.15 from Kelvin. Let me repeat that. If you add 273.15 to the Celsius temperature in order to get a Kelvin temperature, you undo that. You get a Celsius temperature by subtracting 273.15 from the Kelvin temperature. So we're going to take this 342K, we're going to subtract 273.15. Really should have left an empty slot there because we got two, or moved the K over a little bit, I suppose, because we've got 2 empty slots here. Okay, so we're going to take 342. We're going to subtract 273.15, and we're going to get 78.85. And that's our degrees Celsius temperature, except that we still have to round off. We've got 2 empty slots here. Round it off. We get 7. This 8 makes this 8 round up to a 9. 79 degrees C, and that's our final answer. All right, so that seems like a lot of calculations, and it is kind of a lot of calculations, but it's the same process. The math we used here to solve this problem is stuff you learned in algebra. Nothing new, it's just a lot of it. And you got to be very careful to keep up with everything. Now, here's what students do. They tend to want to take shortcuts. And so they leave things out, they aren't careful with everything, and that's where they make mistakes and get the bad grade. If you're very careful with all the steps, to keep up with everything, to keep everything organized, you know? I mean, how hard is it to keep your room organized? You know, I bet if I looked at your ring binders, I'd probably find some of your ring binders in a mess, because it's hard. You have to kind of work at it to keep your ring binders straightened up. Okay? Well, the same thing is true with math problems that are as involved as this. I won't call them complex because mathematically they really aren't. They just have to keep up with a lot of things. So you got to keep it organized. If you keep it organized, it'll work out and you can get a good answer. Okay? So, but that's how you get the answer. You have to figure out what you need. Okay? You make a list of knowns and unknowns as I did here. Figure out which problem, which of the 4 gas laws fits that. Plug in all the numbers, start doing the math. Get your unknown by itself, solve for it, check your answer to make sure you got it in the right units. And in this case, we had to change our units to Celsius. Okay, and let's do this one as a homework problem then. Okay, if we've gotten this far, you're ready to do this as a homework problem. And then on Monday, we'll start giving you a little more practice before we move on to something else. Okay, so your homework is to do this homework problem. Find the volume of 4.5 moles of oxygen gas at 16 degrees C if the pressure is 742 millimeters of mercury. Okay?